This video is a continuation of our discussion on acids and bases. We left off on this slide with some of the characteristics of acids. Let's review for a second here about dissociation of substances. I picked a couple of substances to dissociate here like we did in the discussion of ionic equations. If we put salt in water, it dissociates into sodium ion, +1, and chloride ion, which is the -1. So when we put a soluble substance into water, it's going to dissociate. Also, something like calcium nitrate. You can review the solubility rules. You know, all nitrates are soluble according to the solubility rules. We get calcium ion, and we get 2 nitrates. That 2 goes out in front, and because nitrate is -1 and +2, we can get calcium nitrate. So just a little review of dissociation. All right, so we can do the same thing with acids. If we have an acid, this is not a real acid, there's no Ha acid. This is A stands for anion or acid, so we have a hydrogen and an anion. It ionizes and forms a hydrogen ion and an anion. It's always going to form, an acid's always going to form a hydrogen ion. Remember, Arrhenius said that's what that's what acids do. All right, so if we put HCl in water, what are we going to get? It's going to come apart into a hydrogen, just like this, and it's going to be a chloride just like that. All right, so what happens if we have H2SO4? So I'm going to pause for a second. You should hit pause for a second and think about what's going to happen there, and then we'll talk about it. Okay, so when we put this one in water, what's going to happen is the hydrogen is going to come off, right? And there's actually 2 ways this can work. One hydrogen can come off, so we have hydrogen just like this. And then that would leave HSO4, which would be -1 like this. Another thing that could happen, depending on the situation, is both hydrogens could come off, giving us 2 hydrogens, and then leaving the sulfate ion SO4 by itself. You can find these dissociation equations in the book if you need to look at them more closely. All right, let's take a second now and look at bases, or also known as alkalis. Here's some substances that are alkaline. Oven cleaner, you don't see that too much anymore. Drain opener, this is tonic water. It's kind of a nasty tasting stuff that's used to mix up drinks. This is the antacid and baking soda, all examples of bases. They taste bitter. If you get them on your skin, they feel slippery because they actually react with the oil in your skin. They also are used, as I said before, as drain opener, and according to the Swedish chemist Arrhenius again, it's anything that produces hydroxide ions. So you can look for this in a base, and for the ones we're using in this chapter, just look for the OH ion, and that'll make it a base. And a strong base is defined as one that completely ionizes when you put it in water. Again, the word strong doesn't mean concentrated. It doesn't mean it does a lot of damage. It just means that it completely ionizes when you put it in water. All right, so looking at ionizing of bases, it's going to be just like it was for acids, except we're going to get, this is B for base, it's going to be some cation ion, it's positively charged, so we'll get this B ion and an OH ion. See, I did the same thing with sodium hydroxide, sodium ion, hydroxide ion. Okay, and again, take a minute, think about what will happen if we have this. Okay, and so in this case, we're going to get a calcium ion, which is +2, and we'll get 2 of the OH, so we just put a 2 out front of this. All right, we're going to stop here, and then we will continue this discussion of acids and bases and see what happens when we put them together in part 3.